Welcome to grade 9 science lessons. In my previous lesson, I discussed reflection of light and sound waves in unit 14. The title of the lesson is Reflection and Refraction of Waves. Today, I will be doing the rest of the lesson. Before I start the lesson, let me introduce you a small magic. You all can join with me to do the magic. Go and get a transparent glass of water like this and be ready with a paper with two arrows. You can see here both the arrowheads are in the same direction. So, I will keep the arrow sheet behind the glass of water. You observe the arrow at the bottom through the glass of water. So, you can see, and now you can see the arrow at the bottom through the glass. Did you see anything? Did you see that the direction of the arrow is changing? Yes, it is due to refraction of light. So, topic of today's lesson is refraction of light. During this lesson, you will be learning how to bend the light, refraction of light in water, definition of refraction of light, refraction of light through glass block, and how the refraction of light occurs through lenses, refraction of light through eye lens, and last, day-to-day instances where we use refraction. Before I start this lesson, I will ask you some questions. How light travels through transparent medium? You learnt in last lesson, light travels in straight lines. So, we call it rectilinear propagation of light. As long as light travels in one medium, it travels in a straight line. If you want to bend the light, what can you do? Can you bend the light using a plane mirror? No, plane mirror reflects light back to the same medium. So, how can you bend the light that is travelling in a straight line? You can use a transparent object for that, for instance, glass or water. To show how light bends, I would like to introduce you a small activity. Here, there is a beaker of water, and to that beaker, I direct a ray of light perpendicularly at the first instance, and in the second instance, I direct inclined ray of light to the surface. So, we will do this activity and see what will happen. You need a beaker with water. You can see this water is not clear. So, I dissolve some soap, or you can add some drops of Dettol to that to make it little turbid. You will realize why I did so later. Now, I will direct a ray of light perpendicular to this surface. So, you can observe the light ray inside the water. And now, I will direct a ray of light at an angle. We call it inclined ray. So, you can see the light ray through water. Observe whether it is in the same direction I am directing the light to the surface. You can see the light ray is bent. So, based on that activity we have just done, we will answer the questions. What happens when a light ray is entering from one transparent medium to another? If it is falling perpendicular to the surface, it is not bending, and if it is falling at an angle or inclined, light ray is bending. What are the two transparent media through which light ray travels? Here in the previous activity, two transparent media we used is air and water. What is the place where light ray bends? It is the surface where the air and water is contacting. We call it interface. Why soap is mixed with water? I told you at the beginning of the activity to think why I got a turbid water. It is to observe the ray of light or beam of light in water clearly. If it is transparent, you can't observe the ray of light. That is why I used turbid water. What happens when light is directed perpendicular to the water surface? You saw it already. It will not refracted. Now we will see a ray diagram for refraction of light from air to water. What is a ray diagram? I explained it in my last lesson too. Ray diagram shows the way light rays are travelling. This is the ray diagram for the activity we have done. You can see here two transparent media we used, air and water. So, this is the interface, and this is the light ray that is falling on the interface. We call it incident ray, and this is the point where the light ray hit the interface. We call it point of incidence, and this is the light ray that is transmitted through water. We call it refracted ray. Angle between the incident ray and the normal is called angle of incidence, and angle of refracted is the angle between the normal line and the refracted ray. This normal line has been drawn to the interface perpendicular to it at the point of incidence. So, normally we use dotted lines to draw the normal. Next, we define what the refraction of light is. Refraction of light is changing the direction of light when travelling from one transparent medium to another transparent medium. We will learn it by breaking it into small parts. Change in direction, what is the meaning? Bending light, and when the light is travelling from one transparent medium to another. The two transparent media we used here is air and water in the previous activity. Now we learned what the refraction is and how the refraction happens. Now let us see what is the reason for bending light. You know that speed of light varies from one medium to another. Because of the speed of light differs from one medium to another, light bends when entering from one medium to another. So, this table shows you the speed of light in different media. So, in vacuum or air, speed of light is 3 into 10 to the power 8, and in water it is 2.3 into 10 to the power 8. Speed of light varies from one medium to another. You can see it clearly from this table. When the medium changes, speed of light is also changing. Because of that, light when entering from one medium to another, it bends or get refracted. Let us see how light rays are travelling from rarer medium to denser medium. This diagram shows how light ray is travelling from a rarer medium to denser medium. Rarer medium we used here is air and the denser medium is glass. You can see light ray is coming from the rarer medium and it strikes on the interface at the point of incidence. So, once it is refracted through the glass, you can see the refracted ray here. So, it is very clear to you that refracted ray bend towards the normal. Whenever light ray is travelling from rarer medium to denser medium, light ray is bending towards the normal. Let us see how light rays are travelling from a denser medium to a rarer medium. This diagram shows how light ray is travelling from a denser medium to rarer medium. So, glass is the denser medium here and air is rarer medium. So, this is the ray that is coming from the denser medium. At this point, we call it point of incidence. Light ray get refracted. So, you can see the refracted is travelling away from the normal. So, remember that when light rays are travelling from denser medium to rarer medium, it refracted away from the normal. Now, we will see how the refraction of light occur through a glass block. Here we have to do a small activity. Before I do the activity with you, I will introduce you the things you will need. You need a glass block, white paper, laser torch, a ruler, pencil and a protractor. I have a small video to show this activity. Let us watch the video. To do this activity, you will need a white paper, a glass block, pencil, ruler and a protractor. Keep the glass block on the white paper and draw the margins of it. And mark a point somewhere in the middle and keep the protractor on it and mark the 90-degree angle. Then connect 2 points in order to draw the perpendicular line to the surface. So, the perpendicular line should not exceed to the bottom level and we can name it as normal. Then direct a thin ray of light to the point of incidence and make sure that it falls on the exact point of incidence. And you can mark the light ray that is coming through air to the glass block using a pencil. Then you can observe the light ray that is coming out of the glass block. You can mark a point on the light ray that is emerging out of the glass block like this, and carefully mark the point where it is emerging out of the glass block. Now remove the glass block and you can connect these 2 points to get the incident ray. So, that you can mark the direction using an arrowhead. Then draw the emergent ray as well in the same way and mark the direction using an arrowhead. Then you can connect the 2 points in the middle of the glass block. Observe that the incident ray and the emergent ray are parallel, but the refracted ray is bending towards the normal. So, this is the ray diagram you obtained by doing this activity. Now, you all watch the activity to demonstrate the refraction of light through a glass block. Now, we are going to do the activity here. You will need glass block, white paper, laser torch, ruler, pencil and a protractor as I explained you earlier. So, we will do the activity. Here you have the white paper and I will keep a glass block on it. Now, I am going to draw the margins of it using a pencil. And remove the glass block and I mark a point somewhere here. Using the ruler, I draw a line at an angle. I will keep the glass block again on the same place. Now, I am going to direct a ray of light along this line to the glass block. Now, you can see the light ray coming out of the glass block like this, and I mark it using a pencil, and I also mark the point where it is emerging from the surface. So, I remove the glass block and I connect these 2 points to get the ray that is emerging out of the glass block. So, this is my incident ray and this is the light ray that is moving out of the glass block. So, I will connect these 2 points to get the refracted ray, and I draw the normal to this surface . Keeping the protractor like this . And I draw the normal to this point as well . This is the incident ray that is falling on the glass block, and this is the refracted ray that transmit through the glass block, and this is the emergent ray. You can see the direction of the incident ray has changed here. Here, if I keep the ruler like this, you can see it has changed. It bent towards the normal, and when it is passing out of the glass block, it again changed the direction here. So, this is the refracted ray that is transmitted through the glass block, and this is the emergent ray. So that you can see the emergent ray has bent away from the normal. So, one more thing you can observe here, the incident ray and the emergent ray are parallel to each other. So, this is the ray diagram we can obtain by doing this activity. This is the same ray diagram we obtained by doing the activity. Here is the incident ray, refracted ray and the emergent ray. When light is incident on an object, all the light rays are not get refracted. Some of it is reflected too. In this activity, we neglect the refracted ray of light. With that knowledge, we will move on to the refraction of light by lenses. This is biconvex lens. You know, biconvex lenses are converging light rays into a certain point. When a parallel beam of light is falling on biconvex lens, this is how it is getting refracted. Here is the ray of light falling on this surface, and this is the normal line that has been drawn at this point of incidence to this surface. So, you can see light ray is bending towards the normal. So, that this light ray is coming from air to glass. So, this is the rare medium and this is the dense medium. So, it bend towards the normal, and when the refracted light ray hits on the second surface, this is the normal, and at this point of incidence it bend away from the normal. That is because this light ray is emerging from glass, the denser medium, to air, the rarer medium. Same way, this light ray is refracted through the biconvex lens and collecting to this point. This is biconcave lens. Here you know that biconcave lenses are diverging light rays. When a parallel beam of light is falling on biconcave lens, this is how it is getting refracted. Here this ray is falling on that point, this is the normal. So, this is the rarer medium and this is the denser medium. So, light bend towards the normal, you can see it here, and when it is emerging, this is the normal line. So, light bend away from the normal. In that way, light rays are diverging. Let us see refraction of parallel beam of light through concave lens. You know that after refraction, light rays get diverged from concave lenses. Here, light rays appear to diverge from a certain point. We call it a focal point or focus. Same as biconvex lenses, the distance between the lens and the focus is known as focal length. With that knowledge, we will see refraction of light by eye lens. Remember unit 2 in your science book? We have done these things in unit 2 as well. So, this is the structure of eye. You can see this is the eye lens. You can see light rays that are coming from far away object getting refracted from the eye lens and collected to this point. We call this retina. It is the place where the image is formed in our eye. This diagram shows a nearby object and light rays coming from the nearby object refracted from the eye lens and form the image on retina here. You can see that the image is inverted, not upright. So, how you see things? You see things inverted or upright? We see things upright, but you can see here image is inverted. How we see upright image then? This is done by the structure, we call it optic nerve. So, this nerve send the message to the brain and brain interpret this image as upright one. So, remember in my previous lesson I taught you to see the things around us, reflection of light is important. Now you know not only the reflection, refraction of light is also important to see the things around us. Next we will do some day-to-day instances where the refraction of light is used. This is a very common example. Almost all of you have been near a swimming pool. When you go near a swimming pool, you might think that it is not that deep, but don't jump. It is deep, but you see the swimming pool shallower than that it really is. We call it apparent elevation of the bottom. This is due to refraction of light. Next, an object placed at the bottom of water appears to be raised. So, this is the swimming pool I told you earlier. So, this is the real depth. Here you can see this is the real depth of the swimming pool. A light ray coming from the bottom, when it hit the surface, it bends away from the normal and reach the eye of the observer. So, to get an image, at least you have to draw two rays. So, you can see two rays are travelling towards the eye of the observer. So, if you extend these two rays behind, you will get the place where the image is. So, this is called the apparent depth of the swimming pool. So, it is very clear to you that real depth is more than the apparent depth. In this diagram, you can see a brick at the bottom of a water tank or swimming pool or somewhere, and then two light rays are emerging out of it and bend away from the normal, because these light rays are travelling from denser medium to rarer medium. So, if you extend these refracted light rays behind, you will get the image. So, we call it virtual image. The one above the water surface can see the image here, but the object is not here, it is somewhere below that. This is what is called raising the objects when you observe through water due to refraction of light. Next incident due to refraction of light is the formation of spectrum of 7 colors. When a white light is directed on a prism like this, it separates into 7 colors. So, that is what is meant by the spectrum. So, reason for this is refraction. What is dispersion? Separation of white light when passing through prism is known as dispersion of light. When the white light is travelling in air, all the components of it, that is all the 7 colors, has same speed. But when the white light enters into any other media other than air, these colors have different speeds. So, because of that, inside the glass prism, different colors bend at different angles depending on the speed of light in the glass. So, here in this picture you can see violet color bends more and red color bends less. That means violet is refracted more here than red. So, this is the spectrum you obtain. It consists of 7 colors. So, let us read colors from the bottom. V for violet, I for indigo, B for blue, G for green, Y for yellow, O for orange and R for red. I will tell you a short way to remember this. You can call this as Vibgyon. Then you can remember the colors of the spectrum in order. Next incidence related to the refraction of light is this. When a pencil dipped partially in water, as you can see here, it seems to be broken at this interface. So, this is due to refraction of light from water to air. You can do this at home and see whether you also can see this. This is the most interesting effect of refraction of light, that is the formation of rainbow. Do you like to see rainbow? Yes, you all have seen rainbow. So, but you do not know how the rainbow is formed. This diagram shows how the rainbow is formed. So, this is the white light that is coming from the sun and this is a raindrop. So, you can see the white light is separated into its 7 colors. So, here white light get refracted. As I told you earlier, violet light is refracted more than the red light. So, when it hits on this surface of the water droplet, it is getting reflected. We call it internal reflection, and reflected light rays reach the eye of the observer. So, that this is what we see as the rainbow. So, here light is dispersed into 7 colors by a single water droplet. Not only a single water droplet contribute to the formation of rainbow, large number of water droplets contribute to form a rainbow. So, let us see the processes that involved in the formation of the rainbow. As I told you earlier, rainbow occurs due to combine of 3 effects: refraction, here the white light is getting refracted and here it is reflected, we call it internal reflection. Not only these two, the dispersion of light also contribute to form a rainbow. To observe the rainbow, what are the conditions that should be fulfilled in the environment? To observe rainbow, you should have both sunlight and drizzling. That is, water droplets should be present in the atmosphere with sunlight for the rainbow to occur. Let us see some more effects of refraction of light. To form images of object in front of eyes, refraction of light is important. And refraction of light is also used in making spectacles. We wear spectacles for some eye defects. You know, there are two main eye defects, long sight and short sight. This is how you wear spectacles for long sight, and this is how you wear spectacles for short sight. Long sight is the eye defect where you can't see nearby objects. On the other hand, short sight is the eye defect where you can't see distant objects. Spectacles made for long sight should contain a lens like this. So, you can see light rays coming from the nearby objects is refracted through this lens and collected to this point. We call this point retina, forming the image, so that people who are having long sight can see the objects nearby when you use a lens like this in their spectacles. So, in making spectacles, refraction of light is important. When making spectacles for short sight, we have to include a lens like this. So, you can see light rays that is coming from far away object are focused on this point called retina, so that people who are having short sight can see the far away objects clearly. So, remember, when making spectacles, refraction of light is useful. And last, twinkling stars are also due to refraction of light. With that, we finished refraction of light and reflection of light. So, we will move on to some revision questions based on the lesson we have done. Question number 1. A ray of light was projected to a prism and path it travelled was drawn by a student. You have to select the correct ray diagram. We will see one by one. Here, light ray is entering from this side and it is travelling in the same direction. Can that happen? No. Now you know light ray is bending here. So, answer 1 is wrong. Here, this is the incident ray. If you draw the normal like this, you can see the refracted ray is bending away from the normal. So, can it happen? No, it bent towards the normal. So, this is also wrong. In this diagram, you can say light ray is entering to the prism like this, and if you draw the normal here, you see the refracted ray is bending towards the normal. And let us see this point as well. In this point, if you draw the normal like this, light ray is bending away from the normal after getting refracted through the prism. Let us see the fourth answer as well. Incident ray is directly going through the prism and refracted in this way. So, it won't happen like this in this point. So, the correct answer is this, number 3. Question number 2. Which answer shows correct image of an object placed in front of a plane mirror given here? Here is the plane mirror, in front of it an object is kept. We will see the answers. You know that when an object is kept in front of a plane mirror, image is laterally inverted, that is, left side and right side is changed. Here this is the object. So, this is the image where the left side and right side is changed. So, answer is number 3. Question number 3. I have put 3 statements here. Statement A, regular reflection done by rough surface. Is that correct? No. Regular reflection is done by smooth surfaces. Statement B, image formed by plane mirror show lateral inversion. That is correct. C, when incident ray lie on the normal line, it is not reflected. That is wrong. You know, when ray of light is incident on a plane mirror on the normal line, it is reflected back in the same direction. So, C is also wrong. So, the answer is 2. Only B is correct. Question number 4. A ray diagram of a reflection of light by a plane mirror is given in the diagram. You have to calculate the angle of incidence. So, these are the 4 answers you are given. How do you calculate this? Now, you are given the angle between the surface of the plane mirror and the incident ray. So, you have to calculate this angle. This is the angle of incidence. Here, you know, this is the normal line to this surface. So, this total angle is 90 degrees. So, that you have to subtract 35 from the 90. So, you will get the answer as 55. So, the angle of incidence here is 55, third answer. Then we will move on to some essay type questions. Question number 5. This is a ray diagram of an activity done by a student. This is the ray diagram. What he did was, he kept a plane mirror on XY. So, he projected a laser beam like this on the line AO and draw the reflected ray. In step 2, he removed the plane mirror which was kept here and then he placed a glass block on XY. After that, he projected a laser beam through AO and then he drew the refracted ray as well. So, what you have to do is, by looking at the picture, you have to find the reflected ray first. The reflected ray here is OQ, and then you have to find the refracted ray. The refracted ray is OP, and then you have to find the incident ray. So, this is the incident ray. Incident ray here is AO. Next, again you have to find the angle of reflection if the plane mirror is on XY. Here again you are given this angle, that is the angle between the mirror surface and the incident ray. So, you know this is the normal and this angle is 90 degrees. So, by subtracting 60 from 90, you will get angle of incidence as 30 degrees. So, angle of refraction is also 30 degrees, that is this angle. This is because laws of reflection say that angle of incidence is always equal to the angle of reflection. Next question, name the type of reflection if following things are kept on xy. On xy, if we keep a plane mirror first, what is the type of reflection? Remember, it is regular reflection. If you keep a plane mirror here, you can see regular reflection. And if you keep an aluminium foil here, you can see diffuse reflection. Question number 6. So, there you are given a picture of two phenomena related due to light. You have to identify them. What is this? It is reflection of light, and diagram 2 is refraction of light. Next part, name a natural incident related to the phenomena in diagram 2. So, you are asked to write a natural phenomena related to refraction. So, you can write the occurrence of rainbow. Question number 7, diagram of dispersion of light by a prism is given and you are asked to define what the dispersion is. Dispersion is separation of white light into 7 colors, and you are asked to name the colors P and Q. As I told you earlier, this is the color Q. What is Q? Q is violet and P is red. Red is refracted less and violet is refracted more. Complete the following ray diagrams. You can see here light rays falling on the surface, so it should go in that way. In second one, a parallel beam of light is falling on a plane mirror, so it is reflected as a parallel beam of light. And here a parallel beam of light is falling on biconvex lens, so light rays are converging to one point, and in biconcave lens parallel light rays are diverging. So, this is the answer. Identify the incident. So, this is the formation of rainbow. Name the phenomena related to above incident. So, the answer is refraction and the internal reflection. Write 2 factors necessary to see a rainbow. You know the bright sunlight and drizzle should be present to see a rainbow. Name the scientist who showed that white light is composed of 7 colors. Sir Isaac Newton is the answer. State the colors of the spectrum in order: violet, indigo, blue, green, yellow, orange and red. Remember VIBGYOR? Last question. Write 2 differences between reflection and refraction. Whenever you have to compare 2 things, it is better to prepare a table for that. So, this table gives the differences between reflection and refraction. Reflection occur in one medium, whereas refraction need 2 media to occur. Incident ray and reflected rays are in same medium in reflection. On the other hand, in refraction, incident ray and refracted ray travels in different media. So, before I wind up the lesson, let me conclude what we have done today. We did refraction of light through water. We defined refraction. We learned reasons for refraction of light and refraction of light through glass block, refraction through lenses, refraction through eye lens, and at last we did some incidents related to refraction of light, like apparent elevation of bottom of a swimming pool, pencil dipped partially in water seems to be broken, refraction of white light through prism, and at last we did occurrence of rainbow. With that we finish refraction of light. I hope you enjoyed the lesson and understood it. Please do some revision questions to be familiar with the lesson. Have a nice day. Goodbye, children.